Hello and welcome back to another episode of my Quest System series. In today's video we are going to wrap up the implementation of our hunt template, but before we do that there are two features that I want to add to our master enemy class. The first thing is that currently we could attack the enemy, and if it hasn't seen us before, it will just go on patrolling and won't notice us. The fix for that is really easy. Just go to our master enemy class and let's go to the event graph. We will find our on-C pawn, and here we will add a custom event. We will call that on actor noticed. Give it an input, which will be the actor, and that has to be of the type actor as well. Actor reference. Then connect that to the branch, disconnect our on-C pawn. Then we will plug in the actor for the equal get player pawn, and also connect him to the object value of player blackboard key. So now we've got a custom event for that, and when we see a pawn we will just call on actor noticed, connect the pawn as the actor, but we will also go to event any damage, and if our health does not equal 0 we will call on actor noticed and connect the damage causer as the in actor here. Now that should be fixed. The other thing that we want to do is, currently our enemy will follow the player permanently when it has seen him once, and in most RPGs or MMOs there is some kind of maximum distance that the enemy will follow the player, and afterwards it will return to its original location. So we're going to do that as well. Let's go to our blueprints, characters, enemies, enemy blackboard. We will add a key here of the type float that is called maximum, or let's just call that movement radius. And we will also add another key of the type bool, which is called is running back ? Save that. Afterwards we will go back to our master enemy class. Here we will create a new variable called movement radius, which will be a float. Put that in our children defaults category. Let's give that a default value of, let's say, 1500 units. Also we will need to set our blackboard key on event begin play. So let's add some space here, drag off of the blackboard, set value as float. Again, for the key name, like we did before, we have to make literal name. Type in movement radius or copy it from your blackboard. And we will have to connect our movement radius here. Okay. Also, I will add another function here called is playing montage ? It will have an output of the type boolean called out, and what we'll do here is just get current montage, and we will check for is valid. Connect that to the out, select a function and make it a pure function. Okay, compile and save. That's it for our master enemy. Now we need a task to basically check the distance between our spider and its original location. But we won't do that using a task, we will add a service for that. The difference between a task and a service is that a task is just executed once, and you can set up services to fire with a specified interval. So, for example, every 0.5 seconds we will call our distance check. To create one, we will just create a new blueprint class, then type in service, and select the BT service blueprint base. Call that service underscore movement radius check, and double click to open that up. Here we will need some keys. First one will be the starting location. That will be a blackboard key selector, editable and exposed on spawn. The next one will be the movement radius. Also a blackboard key selector, editable and exposed on spawn. Then we will need one more that's called has seen player ? Again, check editable and exposed on spawn. Afterwards we also need is running back ? Again, editable and exposed on spawn. And then we will need one more variable, which is just called enemy, and that's of the type master enemy reference. File save. If you want to override how a service works, you will have to right click and search for event tick AI, event received tick AI. And what we will do here is get the control pawn, cast to master enemy, and we will set that to our enemy variable. But we only want to cast if our enemy variable is not already valid. So you can just drag in the enemy variable. And now we could just search for is valid. Or what you can also do is right click on the variable and convert to validated get. So now you get that variable and you have access to two pins here, is valid, is not valid. Connect the is not valid to the cast. Afterwards we will add a branch. Connect that to the is valid path and the is not valid path. Now what we'll check here is that our enemy's actor location, get actor location, minus vector. Then we will subtract the starting location that we first have to get as vector. And then we'll get the length of that, which is just the distance between the current location and the starting location. Then we will check whether that's greater than the movement radius that we have to get as float. And we also want to check for another condition, because we don't want our enemy to run back when he's currently attacking. So we will drag in the enemy is playing montage, and we will add a not boolean. Connect that to the end, then connect the end to the condition. And if it's true, we will get the is running back set as boolean. Set that to true. Drag in the enemy, and then we will right click, search for AI move to, connect the enemy as the pawn. The destination will just be our starting location. Again, we have to get that as a vector first. Check the stop on overlap and get an acceptance radius of something like 50. On success, we want to drag off of the enemy, get the character movement component, character movement here, and set the maximum walk speed back to 200. Remember that we increased that to 500 when we saw the player. So now we will reset that. Then drag in has seen player, set as boolean, set it to false. Also get the is running back, set as bool, this time to false. And finally we will drag in our enemy and set its has seen player boolean to false as well. Okay, that's it for our service. Now we also have to add that to our behavior tree. So let's open up the enemy behavior tree. Select our sequence here, move that down, and instead we will add a selector here. Connect that to the selector above. Alt click on the sequence to remove the pin here. Then we will add a decorator, blackboard based condition, because we only want to execute that when has seen player is set. The abort method will be both. Then we've got our selector here, and we also want to add a service here. Service movement radius check. You can see that appearing here now. Starting location will be original location, movement radius will be movement radius, has seen player will be has seen player, and is running back will be is running back. Then you can define an interval and a random deviation. I will leave the interval at 0.5 seconds and the random deviation I will set to 0. Then let's connect the selector to a sequence here. And we will add a decorator to a sequence, Blackboard based condition. And that will be that is running back is not set, and it will abort self. Okay, that's already everything we had to do for our behavior tree. So let's see whether it's working. Okay, so we've got our spider here. If we attack it from the back, it will attack us. Now let's pull it away. And you see that it returns to its original position, and then it starts to patrol again. Now what you can also do is reset the spider's health to maximum health, but that's something that you should be able to implement yourself. Alright, the other thing is that I want to complete our hunting template so that it updates when we kill an enemy. First thing here is to go to our quest system, blueprints, structures, and we will modify the goal info. Here we will add a new variable called goal class. So basically when we have a hunt quest, the goal class will define the enemy that we have to kill. If it's a find quest, the goal class will then be the class of the object that we have to find. That will just be an actor class. And let's move that up. Okay, save it, go to the quest info, save it, and save the completed goal. Then we will go to our blueprints, actors, quest actors, and open up the BP master quest. In our do not touch, we have the current hunted amount. Let's rename that to current hunted amounts, and it will be an array now. I'll save. Then we will go to our setup starting goals function, and before we update the sub goals, drag in our current hunted amounts, resize it. The new size of that will be the length of our current goal indices. Okay, now we also have to update our current hunted amounts when we complete the sub goal and add new ones. So let's go to the complete sub goal function. Here, before we remove an element from our current goal indices, we will add some space, just selecting everything, moving that aside. We will drag in our current hunted amounts, remove index, connect it to the execution, and the index will be the one that we found our local goal index in our current goal indices at. Then we will have to go to our loop, and after we add an array element to our current goal indices, let's also add some space here, because then we will add a branch, and what we will check is whether or not the index of the newly added item is greater than the last index of our current hunted amounts. Connect that to the condition. If it's true, we will drag in our current hunted amounts again and add to it. Then for the element, just type in 0. After we added it, we can proceed with what we did before and also connect it to the force path. Compile, save. That's everything for our BP master quest actually. Now we also have to modify how our widgets work. So let's go to our widgets folder. Then we will go to our subgo widget, to the graph, and we'll add a variable called hunt index of the type integer. Then in our update function, we want to set our hunt index, and we want to set it to our assign quest current goals, and there we will find the assigned goal info here, and the return value of that will be our hunt index. Then we also have to go down to our format text here. For the hunted, we will just get the assigned quest, get the current hunted amounts, and then we will get from that at our hunt index and connect that to the hunted here. Compile, save, close the subgo widget. Then there is another widget that we have to modify, which is our goal entry. So open that up. Here we will also add a variable called hunt index, but this time it will be editable and exposed on spawn. Then we will also open up the update function, and we also have to find out our hunted amount here, but that will be something different because we have to get our state and select. Then we will change pin type to integer, connect the return value as the hunted. When we failed the quest, we will just leave it at 0. When we successfully completed it, the hunted amount will be the amount to hunt. And if it's the current one, we have to get from our current hunted amounts at the hunt index, and then connect that to current. Okay, compile, save that. Then we will need to go to our journal widget, graph, and to the generate subgoals function. Because here in our second loop for the current goals, we have to connect the array index as the hunt index. Compile, save. Afterwards, let's go to our actors, BP Quest Manager, and in the event graph, let's go upwards here and add a custom event, which we will call on enemy killed. It will have one input, which is the class of the enemy that we killed. So it will be a master enemy class. And we first want to promote that to a variable called killed enemy. Afterwards, drag in our current quest actors and run a for each loop. Here in our first for each loop, we will run a second one for the current subgoals of our array element. So add a second for each loop, connect the execution to the loop body. Then we will add a branch here, connect that to the loop body. And let's break our array element to get the assigned goal. First we will check whether the type equals hunt. So is this a hunt quest? And we want to check for another condition, which is that the goal class equals the killed enemy class. Connect that to the end. Connect the end to the condition. If that's true, we want to drag off of the array element of our first for each loop, which is the current quest that we're running through, and get the hunted amounts. Get from that, add the array index of our second for each loop, really important. Then we will add 1 to that, and we want to check whether that's greater or equal to the amount to hunt of our break goal info. For that we want to add a second branch, connect that to the true path of the first one. If it's true, that just means that we killed the last enemy that we had to kill in order to complete the subgoal, meaning that we can just drag off of the array element of our first for each loop, so the assigned quest, and call complete subgoal. Then we also have to find out the sub-goal index, and we can get that by dragging off of our current quest again, getting the current goal indices, and getting from that at the array index of a second for each loop. Okay, connect that as the sub-goal index. Add some rewrote nodes here. So that happens if we killed the last enemy that we had to kill, but if not, so for the false path here, we want to get our current hunted amounts again. And this time we want to set array element. Index will be the index of a second for each loop. And the item will be what we already found out, that is current hunted amounts at the array index plus 1. So we will just increment that by 1. Afterwards we want to update the quest widget for that. Do that, drag off of the first array element here, and we will get the quest widget. Then get the sub-goal widgets. Get from that at the array index of a second for each loop again, and afterwards call update. The last thing that we'll have to do here is to check whether it's the quest that we're running through right now is currently selected in the journal, and if so, we want to update the journal. So again, drag off of the first array element, search for selected in journal, add a branch here, connect the out to the condition, update to the branch. If it's true, get the main widget, get the journal, and call generate subgoals. Connect that to the true, and that's it for our onEnemyKilled event. If you're following the series right now, make sure that you connect the correct array indices and array elements. So I would suggest you watch part of this maybe twice so you get that right. The last thing we'll have to do is call our onEnemyKilled, and that we will do in our master enemy class. Event graph. Let's first go to the event anyDamage. Let's remove that part where we're doing the sequence. We will just call onDeath. Then we will go to our onDeath event. And right before we go into the delay here, we will get killed by actor, cast to third person character. If the cast was successful, we first want to add experience points and connect our EXP for kill as the amount. And then we want to get the quest manager and call on enemy killed. For the class, you just have to type in get class, and as the object, get a reference to self. Afterwards, we will go into the delay and also connect the delay to the cast failed. Alright. Before we can test, we actually have to set up our test quest class to use the master enemy class or the spider class, whatever you want. So go to our quest actors, quest test 1, and here our first sub goal is already of the type hunt. The additional name will be spider, the amount to hunt will be 2, and the goal class will be master enemy, or if you already created a child class called spider, then you would select spider there. Or if you want to use another enemy, just select that. Okay, compile, save, and let's play. So when I go to the robo, press E to interact, and I've got my first quest ever. Hunt spiders 0 of 2. If we open up the journal, select the first quest ever. It also says hunt spiders 0 of 2. Let's close the journal so I can see something. Go to our spider. Let's kill the first one. Now it says hunt spiders 1 of 2. If we open up the journal, it also says that right here. And if we kill the second one, the goal was completed, and we've got our 3 new sub-goals. If I open up the journal again, you will see that hunt spiders 2 of 2 was completed. Alright, that's it for this video. See you in the next one.